Alberto, you mentioned today there's going to be a talk about threat and server health monitoring, how to kick out slow, sick members, and the like.
Yep. Actually, it's not me, the one who will be presenting. Will be my colleague Igor Gizdic. Yeah, he's there. He's connected. So.
Yes, Alberto, thank you. Okay, hello everyone. Thank you for attending. So, yes, the discussion that we proposed for today is related to how to monitor the health of the server and consequently the health of the cluster. What are the tools that we have in Geode at the moment? How are they behaving? Which are the circumstances when they are applicable? How do they work? And if we can improve there. Additionally, but also basically the same topic would be how to monitor the threats of a server. What if we have threats that are stuck, and how to deal with these problems. I've set up a PowerPoint presentation that can frame the discussion. So hopefully you will find it useful. I will start sharing. Just give me a moment. It seems I cannot share. Teams tells me that only the meeting organizers and presenters
Let me
can share.
see how I can make your presenter.
Yeah, please do. Yeah.
I think you should be able to now.
Yes, I have a notification that I'm able to do it now. Let's see. Yes, I can share. Okay. I'm going to share my PowerPoint screen. Just give me a second so I find it. Okay. Tell me if you can see it by now.
I think it's just popping up. There it is.
Okay. Do you see the PowerPoint screen?
Yes.
Okay. I don't want to put it to full screen. I think this is readable enough, but please tell me if it's not the case. So let's go slowly through it. I hope that we will have a fruitful discussion because some of the things here are maybe theoretical, but there are some things that we have really hands-on experience and that actually there are basically experiences from live installations as well. So this is the agenda. That's what I mentioned at the beginning. So let's see how we can detect the members that are in any way problematic. Then do we need to improve how we are monitoring the health of the servers, and also how to deal with the stuck threads that really take a long time and they seem to be stuck for good. Okay, I've tried to collect what is present in Geode code and documentation at the moment. I must say that I think that the documentation does not reflect fully the reality, that actually it's working a bit different than it's documented. I don't know, is the documentation wrong or is the code wrong? Let's see. I mean, that's why we are here today to discuss what is the expected behavior. But anyway, what we I think notice is that we don't want a bug, a software bug, for example, that can happen. That has happened in the cases that we've seen that happen in a single server, or possibly since we are running other Kubernetes infrastructure, we've seen that the cloud native behavior sometimes is not perfect, and that we have infrastructure issues that are related with the disk, but also with the network. And that can also impact the health of a server, and then, of course, that can impact the whole cluster as well. We've seen problems that relate to quite isolated incidents, but also we've seen issues that are really impacting the traffic on the whole cluster. and that's what we want to avoid. And therefore, we try to explore the things that are available that can be used. So basically, we want to avoid. Of course, we cannot avoid a single error. There is always a case for a bug, for infrastructure issue. So that's of course possible and expected. But just a single failure, if we don't have multiple failures, that should not prevent the cluster to continue serving traffic, providing service. Maybe just a small hiccup at the moment the problematic incident happens, and the member is hopefully kicked out sooner than later. So how do we avoid the errors from propagating in the cluster and to the clients? So what can we do to remove and then cordon the member, meaning don't start it again until you fix the issue. So maybe it's not enough just to shut down the member if you are going to start it up again, and then you're going to experience the same issue all over again. So these are the ambitions. And also what would be perfect but not absolutely necessary is that the cluster can do it by itself. So meaning that the cluster can understand when the member is basically so slow that it is impacting the rest of the bunch, and that it's now the moment to tell it to disconnect or forcefully remove it, whatever. It can go down nicely, or it needs to be basically kicked out. So that is ideal. But of course, it's also tolerable, and that the application can monitor something and then decide, okay, now is a good moment that the cluster won't do it by itself. Let me kick out this member. So I've checked what we have in the documentation. I'm pasting the links here, but I will not open them. I'm sure that most of the people is familiar with what's written there. So as far as I could find, there are two mechanisms, functionalities, features in Geode that can help us here, and that's these two things. That the first feature that we have is that we can initiate the suspect processing when a member does not reply in configured time. So basically, this is related to a message being sent, and then we are in a reply processor where we are waiting for a reply uninterruptedly. So basically, the only things that can release or stop this waiting is that the actual reply is received, or the member, the problematic member, the member that we are waiting for, basically leaves the cluster. So this is how we can release these waiting threads. So, but what and how to do that? That's the bigger problem, because I think that it's maybe it's not sufficient. That's one feature. I'll talk a bit more about that later. And then the other feature that we have is I can say a bit opposite, because it's there to remove the slow receiver when our server is not able to timely transmit the messages. So they are kind of different, or on the opposite spectrum, because the first one has sent a message and then is waiting for a reply, and the reply doesn't come. But this last one is not when the server is not able to transmit message in the first place, and then it has some timers, and then it triggers some actions if the timer expires and so on. But I mean, let's discuss
more. A quick question.
Yeah, sure.
So I think we're still seeing the title slide. Is that right, or are there more slides? There should be.
Oh, then let me recheck my sharing. Sorry.
I see there's some. I'm the one moving them.
Okay. Sorry. Okay, sorry. It's okay. This is the slide where I was on. Thanks for interrupting me. I was actually looking at the actual PowerPoint program, not the screen share. Sorry about that. Okay, so these are the last two bullets are the features that I was just mentioning. And in a way, they are kind of on the opposite spectrum, and they are also dealing with a different type of messaging and a different type of regions that back them up. Okay, let me move on. Okay, so the first one, the no reply handling. This is advertised in the documentation in how to manage the slow distributed ACK receivers. This is mostly related, and what we see here is this triggers when you have partitioned regions. And the thing is that that if you are using a distribution scope, that's basically from the documentation, other than the distributed NOAC, then we can have a system, a server, issue an alert and also trigger a suspect processing for something that it considers a slow receiver. Actually, somebody does not reply. It doesn't mean that actually it's a slow receiver. It can be stuck for any reason. So it could have received the message and process it, and then the reply is stuck somewhere. It could be that the message is still in the socket receive buffer, for example, and for any reason it's not being processed on the receiving side because you have some kind of deadlock there or a GC issue or whatever. So this is controlled by two settings, the ACK threshold and the severe alert threshold. And basically these two settings are the default value for the wait threshold is 15 seconds. So this means that a thread that waits for more than 15 seconds for a reply is going to trigger the suspect processing. And so this basically means that it's going to send a heartbeat, is going to do a TCP check, and if the member replies or the TCP check succeeds, then the thread considers this as a live server and continues to wait. I doubt if this is the correct behavior always. Sometimes it is, but I'm not sure if this is always the correct behavior, because just the fact that the other VM is alive does not necessarily mean that it's healthy. And as far as I can see, I mean, the health of a server basically is just if it can send me back the TCP ping and reply, actually. So it just needs to have a thread there, enough resources to spawn a thread upon receiving a TCP connection request, and then read something from a socket, write something back to the socket, and that's about it. I mean, it doesn't say anything if there are deadlocks in this server, if there is a resource contention there, nothing. It's just, I mean, it's very simple, I'd say, to pass this TCP check. Basically, you need to have the process up, and that's it. Then finally, if we have the second setting switched on, it's off by default, so the alert threshold is set to 0. With this, we can tell the server to emit basically an alert saying what's wrong, and then this can be this is basically broadcasted via JMX to a listening application. So with this, we can have the client application noticing that there are threads in the cluster in some servers that are complaining about some other member. So I've pasted here how that looks like. So there is the information exactly which server is complaining, on what message is being waited for, what is the current view, and so on. So theoretically, the user application, although the cluster by itself won't do anything. So if the suspect processing passes, and I think most of the times it's going to pass, we can let the client application act and decide. If it receives too many of these messages in a small window of time, then it can decide, oh, it must be something wrong with this member, and then it's up to the client to react, to trigger the alarm for the operator to notice, and then to check, basically to do a manual check on the cluster. Or it can even unconditionally say, okay, this member is wrong, let me restart it, shut it down, or I mean, any other applicable action. But at least from this, I call it feature, we can, I mean, the application can have a notification that something is indeed wrong with this server. Okay, then a bit more. on the same topic, it's again about the slow distributed ACK messages. This is how this is the link to the documentation that I reference, because there we are telling that we prefer to have conserved socket set to false, because in the case where we have a mix of distributed no ACK and a distributed ACK messages, that it's better to have a conserved socket set to false. So our threads that want to take part in the distributed ACK communication, basically they that deal with partitioned regions will have their own sockets. So in that case, we can have a slow processing of a distributed no ACK messages impacting our distributed ACK messages. But I question if that is so, because the tests that we run show that that is indeed okay if you are running partitioned operations outside of transactions, okay, which is of course maybe a majority of cases. But if you are using the transactionality and you want to open a transaction and then in the context of the transaction you do create operation or an update or whatever, and then you commit that, then actually the waiting server, although you have the conserved sockets switched to false, and although your thread is going to have an exclusive socket to send the commit messages to the server hosting the secondary buckets, actually what we see is that the reply is going to come using the peer-to-peer shared socket. So basically it's going to enter the thread that processes the shared unordered connection. So the reader that is used for so many things. So now the question is this the expected behavior? Do we see a problem here? Is this the how it's supposed to be designed, or maybe it's the bug? Because it looks like that transactional commit does not honor the conserved sockets equals false setting. So you cannot have a different behavior. Probably it's related with the type of the reply message that I mean goes to the via the shared, as I said, the shared out-order connection. My suspicion is that this is a bug, but let's see. But let's see. I wonder what the others think about that.
Yeah, I can give a little background. I think the conserve sockets flag was, I think, introduced as sort of a performance tuning thing, right? So you can basically set it to say try to use a socket per connection. But I think there were always cases in certain types of messages that go over these shared connections. So it's not. I think the setting is not every single message is going to go over a thread-owned socket, but that we're trying to basically not conserve sockets. We'll use more sockets to get better performance. So it's possible. I mean, it's possible in this case. Maybe we could get better performance if this particular reply went over a different socket. But I'm not sure that I wouldn't say that the contract for conserved sockets is that everything uses a thread-owned socket. I do remember a little bit about this. There were issues at one point with like serious socket proliferation, right? Because you have a thread in one member sending a message to another member, which sends a message to another member. Like each one of those has a receiving thread, so you kind of have this exponential growth of threads and sockets. I think there were some things that we kind of said, okay, well, this should go back to a shared socket, so we stopped that exponential growth. So it's possible this is one of those cases.
Yeah. Okay. Thanks. I mean, the experience, at least that I have, is that basically the global conserved socket setting is basically only honored by server connection threads and basically nothing else. So if you want the other thread pools to honor it, then you need to code that in, and yes, you have some control over it, because if you have a function execution thread doing it, then your code can take care of using the exclusive socket, but you can't do anything about server receiving, receiving the operation that you triggered in another server using the function. So the type of message will decide on the thread pool, and it seems that most of the thread pools actually do not honor the conserve socket setting. So you could be again, queuing and sharing connection with all the other activities that are, using a shared connection. So would you consider then this to be a bug or not?
I guess I wouldn't necessarily consider it a bug if it's going back over a shared connection. Like I said, I think the conserve sockets wasn't saying every thread, every message everywhere is going to go over a thread owned socket. I mean, that said, like I think it's perfectly reasonable to experiment with saying, okay, what if we, make this set of messages or this set of threads use these thread owned sockets instead of shared sockets, and see what the effect of that is. I think it's a performance tuning thing, right? It's like, okay, do we use more sockets and more threads, and does that get us better performance, or does that get us worse performance, or cause more resource issues because we run out of sockets, or run out of memory for socket buffers.
Hey, Dan.
Yeah.
One other thought in this area, like, are the commit messages being sent on a thread-owned connection, or is that also using a shared connection?
No, that's fine. No, that's
it's
fine.
just the reply.
Yeah, exactly. Just the reply.
I remember, and I think, Dan, you worked on this. Originally, the replies had to be the very simple ACK, because it was sent back directly on the thread-owned connection that sent the message. And you did this enhancement. I think it's called you added an interface direct reply, and you made an enhancement so that all the cache operation messages could direct reply. It might just be that we need our TX commit message to implement that. Direct reply.
Exactly. I mean, it was not that complex to fix it and to have the reply going over exclusive connection. It's just that's not part of the the current source code. So it looks like it's fixable. I don't see any drawbacks. It seems to work fine, but my take is is this on a conscious level, or just something that should be improved?
Yeah. So what Daryl's talking about is there's different sockets the reply could go back over, right? So like a PR put message, we send over a socket, and then the reply actually comes back on the same socket.
Yeah.
So we have special logic for some of those messages where we send the message and then we're actually waiting to read from the socket. Other things, we send over one socket and then we wait for a reply to come back over a different socket. And so I think that's what Daryl's talking about, is that maybe this TX commit reply is going back over a different socket where it really could come back over the same socket. And that's actually, it's like yet another level besides the conserve sockets false. That's basically some extra machinery for different types of messages. So that reply message, just making that reply message go over a thread-owned socket as opposed to a shared socket wouldn't be as good as saying, let's send it back over as a direct reply over the socket that the original request came from. So that might be, another improvement that could be made there.
Okay, so at least it looks like we could check this out and possibly improve. Okay. Okay. Then let me move on. The other mechanism to supervise the slow members, sick members, is this other one related to the transmission of the messages. This is basically configured from the receiving side, but honored by the sending side. And basically, it's how you can control. The documentation says distributed no ACK receivers. But basically, what I've seen is that if you use the conserve sockets equals to true, then so if you are sharing sockets, then basically this works for partitioned regions as well, because I mean everything goes over the same peer-to-peer sockets. So there are three settings. The async distribution timeout as the main switch to turn this off and on. The default is off, so this is not used. And then if you switch it on, if you switch the async distribution timeout to on, then there are the pair of settings, the queue timeout and the max queue size that you can set one or two or the other or both, that basically control how long the server is willing to wait in milliseconds in time or in the queue bytes before force removing this member. So this is based basically on the socket send buffer from this VM, because if the server is not able to transmit a message in the distribution timeout time, then it basically spawns a new thread for this remote server and basically opens a queue and says, okay, I'm not going to do this synchronously anymore. I'm going to do this asynchronously. I will have a queue, and this queue can be at most max queue size big. And the events in this queue, the messages in this queue need to drain in the queue timeout. If that does not happen, then this member is force removed from the system. So via membership. So that's this. Here we don't have a suspect processing. So this, in a sense, it's I think this feature is better than the previous one. Because here there is no, you don't ask the other member, okay, can you reply to the ping? It's not about just being able to reply to the simplest of TCP messages. It's basically just removal, no questions asked, just go out of the cluster, which is a bit better. But so basically, this, as I say, seems to work for partitioned regions as well. And in my opinion, probably this part of the documentation needs a review and maybe basically an update, because if you read these few chapters, then it's not quite clear when this will trigger. I don't know if you have comments. Okay.
The thing I know is that, go ahead.
Mm-hmm.
Somebody else was about to talk.
No, please. Sorry for interrupting you.
The only thing I know is I think we were a while ago, we talked about removing these features. So it's interesting. I was just looking, they're not actually deprecated. So it's interesting information that you're seeing that this worked, or feel like this was working well.
Yeah, this was working well. If you somehow make the peer-to-peer reader block, or you happen to have a deadlock or artificially block it, and then you see this really switches on, and it's able to remove that member. Yeah. So this works.
Yeah, I mean, this is maybe a higher level discussion. Like, so the membership checks, we're talking about pinging the members. That's really to try to identify members that are like either not reachable or just dead, right? And I think we didn't talk about that, but there's like this whole system of like pinging members in a ring and making sure that they're not there. So there's getting members that are completely dead or unresponsive. Then there's this whole gray area of sick members where we're getting
exactly
here. I think one worry I have about like this sort of mechanism for figuring out if a member is sick is that you don't really know which side is sick, right? Like in this case, I might be getting a slow response, so I force another member out of the system, which I'm not actually quite sure how that works, but maybe I'm the slow one, right? Or maybe this other member is slow, right? So the whole like diagnosing what is correctly the sick member is a pretty complicated problem. So
It is, but probably if more than one server complain about the same one, then probably that one is the problematic one, right? Because I don't expect that that if a server is very slow, probably it's going to be slow to respond to the messages from the others as well. But it will depend how much activity the others have with this faulty or problematic one. So I agree that it's not always straightforward.
Especially some of these deadlock cases, right, where basically maybe you have a thread that's stuck in, member A, and that's causing problems in member B, which causes problems in member C, right? You can kind of have these chains of things. So that's just a general comment. Sorry.
And then, then what I mentioned before, the health monitoring. So, in more than one case, we have the triggering of the suspicion for a member, and basically what we do is there is a heartbeat and then a final TCP check. Is this, good enough? Should we have a suspected member to stop sending heartbeats or fail the final check when something inside it is wrong? So at the moment, the server basically does not care about the rest of its functionality. It just tries as hard as possible just to reply, to send a heartbeat. But should it check something? Should it see if it has some progress? These are just examples that are written here. If you have an asynchronous this writer thread, is it progressing? Is it blocked? For how long? Should it fail the heartbeat if you can't flush the buffer in time or after some time? Then what to do if we have a peer-to-peer reader block, what you mentioned just now? You are going to impact all the other members. Should it do something? Then if all of the thread pools, all threads in a certain thread pool, but then the question is which one, are stuck because of not waiting for the others, but because of the locking internal to this VM. Is this a cause of concern? Should it fail? Should it shut down basically? These are just examples. Probably there are more.
I think I agree that there are some, the simple ping response could be improved in our health monitoring. I think, there have been some experiments done around more heuristic analysis where we don't look at, say, the last response, but we look over a period of responses. Dan, correct me if I'm wrong, but I think that was the phi algorithm that we did some prototyping on. That I think as an overall approach, that tended to have some drawbacks. It was very slow to respond and notice issues, and that's the whole black art here, which is we want to respond quickly enough, but not overcorrect and cause a worse issue. I think there's some interesting ideas here where we could, add an extension point and start, trying out new kinds of probes in our health beat response. So obviously, keeping our ping response, but also we could add probes for things like CPU, internal thread deadlocks, locks on other members, and then we have to think about what constitutes an actual failure and how many of those before we decide to take action on those. But certainly something I've thought about. There are cases where we see even TCP messages failing to be delivered, and that's a very rare condition. But when it happens, things do go sideways, and it'd be really cool if we could find a way to self-heal from those kind of failures.
One thing I think would make sense. Like I think so these TCP checks, these health checks, I mean, that really is trying to diagnose like process failures or network issues, right? That's what those things are really getting at. So if a member can respond to those, you know, that tells you that the member can communicate with the other members, right? So I think that really should be a separate layer from diagnosing if a member is sick. So like, which it does seem like an interesting avenue to explore. So like in my mind, I would say like, okay, these health checks and network connectivity checks should kind of stay the way they are, and we should never, like, if we want to add stuff to diagnose that a member is sick, that should be something that the member itself does to kick itself out, right? So rather than saying other members decide, okay, I'm going to kick this member out because I think it's sick, like if that member can communicate with the other members, like we've already kind of diagnosed that at the membership level, then that member itself should be able to say, okay, I'm sick enough that you should just remove me from the membership view. And that might avoid some of those problems I was worried about, where, you know, if we just base it on, oh, I didn't get a response to this one particular message, I don't really know what's going on over there, right? That member has a better idea of what's going on. Maybe it knows it's waiting for yet another member. But I do think, like, I kind of like Anthony was saying, like it is a black art figuring out, okay, are you really sick? Are you the one that's sick? Is this normal for this system to be waiting this long for this message, or is this abnormal, right? It's definitely a gray area, but I think there, I mean, I think there's definitely stuff we can do better there, right? To figure out some cases.
Yeah, Dan, I could see an interesting case where like in your scenario where, you know, member A is waiting on member B, and it's in one of these situations where it is a long wait for a response, and the heartbeat could tell the coordinator member A is waiting and I'm waiting on member B, and then the heartbeat for B could say, well, I'm waiting on member C, and then C says, I'm healthy, but there's, you know, nothing going on. And then you know, if we get enough of those responses over a certain period of time, perhaps then the coordinator could take some action. But it's a little bit speculative. There's some you know, trade-offs in making those kind of global decisions.
Yeah, and I guess I would almost say to like layer it, right? So the heartbeat should stay just for networking issues, and then we can do that kind of weight tracking at another level. Like we actually have, you know, the whole deadlock. It's like the collect. There's a gfish command that like tries to look for deadlocks,
right?
Kind of track some of those dependencies, right? So, you know, I could imagine, like, after we've been waiting for so long, we could trigger some sort of process that tries to track down the dependencies of what you're waiting on to see, okay, is it really just that member, or is it, like you were saying, the member that member is waiting on?
I mean, if you were in front of such a cluster, then you would, you know, right, check the logs, and you would find it out after, you know, some inspection, some screening. You would eventually find out who's the guilty one, and they probably shut it down, right?
Yeah, and that's the thing, is I think it kind of depends on, you know, you as an operator, like what you really like, how much patience you have, how much time you want to spend tracking these down versus restarting things, right? And that depends on your use case and your cluster, right? Like some, you know, I could see sometimes maybe you're saying, okay, if things get stuck for a certain amount of time, just shut the whole cluster down and restart it. You know, like you could even have policies like that where, you know, somebody would want to communicate, this is how patient I want the system to be, or.
But maybe this idea commented by Anthony about make it pluggable. Okay, that at least you have an extension point that if you know your requirements, at least you can say as an application, Okay, for me this is not good. Okay, and maybe from there, I don't know, you can start to check, for instance, casing queue, or how many threads are stuck, or I mean CPU, I mean whatever you consider, and at least I like also this local validation, and at least you're say maybe you can decide in this pluggable monitoring to shut down, or if not, I don't know, you can publish GMX, and at least when you are investigating, you don't start from scratch, let's say, okay? Maybe the incident has not spread enough, hopefully. Okay, so I don't know if that could be a way to start, okay? To think what is the good architecture to try at least to have some custom logic, and maybe we can, I don't know, potentially improve or not, okay? If today is enough the TCP checks, okay, maybe that's the basic stuff. And at least to, I don't know, to grow from there. I like that approach. For me, sounds reasonable, let's say.
Okay, let's see if we can propose something in the direction. So to have a pluggable, something pluggable, and then you can code your own mechanism.
Does it make sense for you? Do you think it's worthy if we try to elaborate a bit on that? That could be general purpose, or you think maybe it's not of general interest?
I mean, I think this general idea of saying, okay, let's try to figure out if a member is sick makes sense, right? I mean, I think it's a good thing to do. I think it's a question of, yeah, like what types of sickness are we going to look for, and how do we make sure that we don't misdiagnose and kill the wrong thing, or have one sick member kill all the other members because it thinks things, we do things the wrong way.
You can crash the whole thing, yes, if you do it wrong. That's clear.
Right. But I mean, I definitely think like this is an area that seems like it could use some improvement, right? That, yeah, the membership checks are really just like, is this thing reachable over the network, which is not all the things that could be going wrong with that member, right? So the general idea of like trying to figure out, okay, is this member sick? Is it, is it having serious memory GC problems? Is it deadlocked? These are all things that are good to try to figure out. I'm curious. So I think for you folks, what's the first type of sickness that you're interested in trying to handle here? It looks like just slow responses to certain types of messages. Like, do you think that's a resource issue or a deadlock issue, or?
I think it's the deadlock issue. Yes.
Okay.
And then what's written here in the first bullet, the problem with the disk writing. If it's very slow to detect basically infrastructure issues in this way.
Okay.
So these are not common things, of course.
Well, I've definitely seen deadlocks before.
Yeah.
So
Yeah. Yes. We also seen deadlocks when basically a block in the peer-to-peer reader basically takes down the whole cluster. So just a single thread in a single server is taking down the whole cluster.
There is a disk monitor that makes sure there's still free space. Is that useful at all for the no async disk writer thread?
I don't know about.
Do you know what's causing your async disk writers to not make progress? Is it lack of disk space, or is it something else?
Sorry.
I think it is something else, correct? I mean, if I'm wrong, Igor, but usually it's due to some instability on the storage system, right?
Yeah, Yes. Yes, correct.
So it's more of a like a throughput issue
Yeah, yes, it can.
than
It
a
can
out of disk space issue.
Yeah, yes, exactly. I mean, this space is monitored in another way, so it's not being out of this space. No, no.
Yeah, I think it's worth pointing out that for certain infrastructures issues, there's really very little that can be done in the applications running on top of that. Like if it's a slow shared storage system, it doesn't matter if we kill the member. It's going to affect every node in the cluster.
Yes, that very maybe. Yeah. I mean, these are
Somehow,
just.
even if the storage is not there, the problem, at least the worst problems for me is when things are not broken, okay, they answer, but they answer slow. Okay, so imagine a single disk is slow. But you have it's working, but is, I don't know, struggling. And then these things starts to spread. Okay, for me this is the nasty problem, because you are right. If your SLAs are not good enough and affects all the cluster, then I think there is no way out. But I think more the problem is when you have an isolated problem, but somehow it's spreading. Okay, for me this is the kind of maybe use cases that improved monitoring could help to isolate, because actually the solution is find and isolate. Okay, no matter what the problem is. Okay, so can this be automatically, or I don't know if automatically, or at least a warning, a GMX notification could be sent. I don't know, something can be done, or it's like it is, and you need to troubleshoot and fix it. Okay, probably this is the kind of use case more than a general SLA problem, let's say, in the infra.
Yeah, I mean, here you are trying to prevent something, and at the risk you are going to do a false positive action. So that's a trade-off here.
Yeah, the nice thing is like a slow local disk or something is something that's something that to me seems like it would be doable to diagnose locally and have that member shut itself down, right? Like it's a little bit, or yeah, like it's less complicated than having other members try to diagnose that one member, right? It can diagnose itself, which is nice, right? Like in terms of complexity.
Okay, let's move on. Let's try to finish. We have 10 more minutes. Okay, then something I expected that you've seen as well, and we have seen that in the system that have been running for a while, like for 4 months, that we occasionally in the server see threads that are stuck for really long. There is the example here in the screen. I'm not sure if it's readable enough, but it's like a thread that is stuck waiting for result collector. So this was a query that obviously one member did not reply for who knows what reason there. What we always see basically threads that are stuck for very long without any other observable problem in the cluster. So it's not like we have a slow response. It's not like we have obvious issues with members, but still we occasionally see that some of the threads in the thread pool, I think it's always the server connection thread pool is basically stuck. So since we are using the max threads parameter, basically this is taking out our processing capacity. So we lose one thread out of the configured maximum, whatever that is. So over time, this can slowly build up. Of course, you can solve this by restarting this server, but then I mean the question here is How do we detect this? How can we find out if the waiting is the correct one? So meaning yes, wait more because the reply is just about to arrive, or how can we detect that basically this thread is going to be stuck forever? Because I think if it's waiting for 2 months, then it is stuck forever. And what are the actions apart from the obvious one, restarting a server? What are other actions that we can do to release those waiting threads? I don't know if you have experienced these issues and how do you deal with them. They are probably bugs somewhere. They could be also related to infra issues, because there are some occasions where we see that a few threads are stuck around the cluster, so not in a single server, but in more of the in more servers around the same time. So that kinds of points that could be something infrastructure related that somehow has spread in the cluster, not enough to take it down, but obviously enough so that some responses are basically lost forever. I don't know if you have experience with that and how to. I mean, at the moment, I don't think we have a good way to solve this. We can detect it. It's being logged. You have that in the statistics. That's fine. But basically, other than observing it, no other action.
I think I've seen this kind of behavior occur under two circumstances. One, perhaps there's a bug or issue in our messaging code that results in a some sort of cascading failure where a response isn't sent. That seems to be one case. Another case is more, I recall a situation where there was a network cable that was having partial failures. So it's this case, like you mentioned before, where things mostly worked, but occasionally a packet would get dropped and result in some pretty crazy behavior. And that can also result in this kind of situation.
Yeah, that's possible. But what to do? How to detect it? How to solve it? I mean, we don't want nasty actions like restart. I mean, we want to avoid them.
So yeah, because I mean, one more possibility. I don't have a solution yet off the top of my head, but I mean, one more possibility that there is a deadlock on the other side of that message, right, or something else, right? I mean, it looked like that was waiting for a long time for some kind of reply, but it's possible there's other threads waiting on other servers, right, for so it could be whatever is supposed to reply is deadlocked on one of those other servers.
No, the cases where we have specifically checked the logs are not related to the deadlocks on the other side.
Okay.
So it could be more like Anthony said, that either a bug in the reply code, in the messaging code, or the lost packet. It shouldn't be, at least in the cases that we have the logs for. It's not the deadlock in another member. No. But anyway, whatever it is, I mean, the bug is there. It's fine. Okay, the bug is there. The infrastructure issues happen. I mean, that's there. We cannot change that easily, or not in the field at that moment. But we want to get the capacity back, so we want to solve it. Do you think it makes sense to somehow implement a mechanism that can interrupt this thread and return it back to the pool, so you can have the capacity back?
I think that's kind of tricky. Like, well, so in this case, this particular case, like it looks like it's like a function execution processing thread that is waiting for response and going to send it back to the client, right? And I'm guessing that client has probably already given up because it's been 4 million seconds and the client is probably not even waiting anymore, right? for response. So in this particular case, I think we could look at this thread and say, yeah, it would probably be okay if this thread just gave up, right, and stopped waiting. I'm not sure if we can generalize that, right? I think that there are other cases where it wouldn't be safe to stop waiting, right? Like maybe we're in the middle of a put, and there's other logic that's supposed to happen after we get the reply. Like it would not be safe to stop waiting for a reply, in that sort of case. So yeah, I guess I'm not quite sure what the right solution is. Do we like this sort of thing, like this function execution thing? Like it's possible we could say, okay, we will implement like a timeout through the whole chain of the function execution that somebody could set. I don't know if that would solve it everywhere. I mean, I do think like the fact that this one thread is hanging out there is a sign of a bug, right? That needs to get that, it would be good to track down one way or another, right? Like that would be the nicest way to fix it, is figure out, okay, what's the bug that caused the thread to be left dangling and not getting a reply.
Yeah,
honestly, I'm sorry, go ahead.
No, I wanted to say that, I mean, building up of these issues slowly over time, is a problematic thing. Of course, there is a bug that needs to be fixed. Probably is going to be fixed in the next release or two. But the issue is what to do with the site in production that experiences these issues. It's not nice to see it if we have just a quite small number of dedicated threads to serve the clients, than to have 2, 3, 5 of them blocked. It's I mean, not nice to see.
Yeah.
I mean, it would be fine to have a manual way to cleaning. We don't expect that this is automatically detected and cleaned, but what if you had a way that you realize, okay, there are like 4.5 million seconds since this thread is waiting for a reply. Let me release it. So if we could have some kind of interruption points.
Yeah. If I can share a few stories, I think what how we deal with some of these situations when they do occur is that we don't focus on the thread that is waiting for the response. We look at where the thread, the source of where the expected response is supposed to be coming from. So, and that could be a chain of things, like we were talking about earlier, of A waiting on B, waiting on C. If the problem is C, as soon as we take action to say kill server C, then all of these threads will clean themselves up and do the right thing. So, that's kind of a manual process of gathering all the logs and looking for the root of the graph. I'm sure that could be automated based on some log analysis, or adding some extra tools and statistics or other information into the system to make it easier.
How do you get it without a heap dump? How do you know which member is this thread waiting for?
There should be sufficient information in like who's waiting on who to identify the root cause, like the source member that's having the fault. I don't know if you want to dig into that further, but that's like that first level of sort of manual or possibly assisted manual inspection to see and allow an operator to take action. At more of a product issue level, there's a couple things to think about. So The whole point of Geode is that we do consistent synchronous replication, and then in order to ensure availability, we have fast, reliable failure detection. And that goes back to the issues we were talking about earlier with health checks and understanding when a member is sick, still responsive, but in some degraded state. And, as maybe a follow-up investigation or improvement, that might be able to help out. I don't know, Daryl, do you have any more thoughts on the things you've done to find the root cause for these distributed deadlock situations?
No, like what we'd normally look for in the log where we see the stuck thread, we'd look back and look for one of those 15-second warnings saying, oh, I'm waiting for a reply from so-and-so. And that can be problematic if you have rolling logs and there's a lot of log activity. And by the time you see the stuck thread, maybe the warning has rolled off.
Yeah, that's exactly the case.
Yeah.
So we're almost 4 minutes over. Super valuable discussion, but I wonder if we should take the rest to the dev list or have a follow-up and wrap this conversation up now.
Well, thanks. Thanks for providing insights. Thanks for commenting. Yes, I think we should try to have a follow up on some of these topics, in particular the first half of the session about these two existing mechanisms to kick out the members, the no reply handling and kicking out the slow receivers. So I don't know, how do you propose to proceed? We can continue maybe over the mailing list. I don't know.
Devlist is probably logistically the easiest place. We also have a underutilized community Slack channel where maybe we can pull the right people in if we feel that the mailing list is too slow. And we have another one of this meeting next month. This is your topic. You are fully trust you to push this forward in the right way that works best for you.
Okay, and then we'll see and try something. Thanks.
I see at the bottom you have one more slide. Should we get to that or?
No. We were there already.
Awesome.
It's just a summary. Of,
in that case, thank you so much, Igor, for presenting, and thanks everyone for the participation and joining the session today. And see you on the dev list or next month.
Thanks everybody.
Okay, thank you. Bye.
Thank you.
Bye-bye.